Hello everyone. Today's video lesson is on system of inequalities. In this video we are going to be talking about determining if a point is a solution to a system of inequalities, as well as learning how to graph a system of inequalities and shade to represent the whole solution region. All right, let's get started. Okay, systems of inequalities. Systems of inequalities are a nice springboard off of what we did last class when we talked about how to graph two variable inequalities on a coordinate plane. We can have systems of inequalities just as well as systems of equations or equalities. The definition of solving a system still holds. We have to find all points that make all inequalities true. So just like when we were looking at a system of equations and we did linear systems of equations and we would graph the two lines on a coordinate plane, what we'd be looking for is the point for which worked in both of the lines, and that showed up on the graph as the point of intersection. Well, now if we're graphing a system of inequalities, we're going to be seeing two inequalities graphed on the same plane. And remember, when we graphed a system, when we graphed just an inequality last class, you had a whole slew of solutions, okay? You were shading. Everywhere where we shaded was a solution. Well, now if we graph two of those, the overlapping shaded areas become all points that work in both inequalities. Okay, so we're going to take a look at exercise number 1 here. And it says, consider the system of inequalities shown below. So it's kind of tucked over in the corner here. This is the system of inequalities that they're talking about. All right, it says, determine if each of the following points is a solution or not to the system. Show work that justifies your answer. Okay, so we're going to talk about how we can, without even looking at the graph yet, oftentimes these are multiple choice questions. How can we see if the point 3, 8 is in fact a solution in this system of inequalities? Well, in order for it to be a solution, it has to work in both equations, okay, or inequalities. It has to work in both. So we're going to write that down. Must work in both. Okay, so that's important. All right. Now, if I want to test to see if this point works in both, well, remember how we tested to see if it worked in one. We recognized that each point is x comma y. So I am going to take this point, 3 comma 8, and plug 3 in for x and 8 in for y in each of these inequalities. So if I take the top one, it just says x plus y is greater than 10. So I'm going to go ahead and replace the x with 3. Replace the y with 8 and ask, is that greater than 10? Some quick computing will tell me that 3 plus 8 is 11. Is that bigger than 10? And I would say, yes, it is. So I'm just going to put a check mark. Yes, it is. Okay, then I'm going to move on to the second one. All right, the second inequality. And I'm going to say, is y, which is my 8, greater than or equal to 3 times my x, which is 3, minus 5. So is 8 greater than or equal to 3 times 3 is 9, minus 5 is 4. Is 8 bigger than 4? Yes, it is. Because it works in both inequalities, I can go ahead and say, yes, it is a solution for the system of inequalities. Okay, so letter B. Let's go through and try it again. Again, we have a point x comma y. So I'm going to go ahead and put 5 in for x and 9 in for y. All right, so I go ahead and put 5 plus 9, is that bigger than 10? And yes, it is. Okay, 14 is greater than 10. All right, now I test the 5 and 9 into the second inequality. So 9, is that greater than or equal to 3 times 5 minus 5? So 9, is that greater than or equal to 3 times 5 is 15, minus 5 is 10. Is 9 greater than 10? No, it is not. So we would conclude that that 5, 9 is not a solution. Okay, and so it's important that you recognize it worked in one of the inequalities, but it didn't work in both. So it's not a solution. All right, Part C here asks us to go ahead and graph the solution set to the system of inequalities. Well, guess what? We are going to take each inequalities and we're going to graph them one step at a time on the same coordinate plane. So x plus y is greater than 10. All right, so the first thing I need to do from last class is get y by itself. So how do I do that? I'm going to go ahead and subtract x to both sides. So I would get y is greater than 10 minus x. Now if you remember, we unpacked some information before we went to the graph paper. We asked ourselves for the slope, for the y-intercept, and then we talked about if it's solid or dotted, and we also talked about if we shade above or below. So what is the slope of this? Remember, the slope of a line is located in front of the x. So my slope here, okay, is -1. So I'm going to go ahead and put -1. All right, my y-intercept is the number that's by itself, which here is 10. Okay, ask yourself, is this going to be a solid or dotted line? And hopefully you're telling me dotted. Okay, am I going to shade above or below? And in fact, I'm going to shade above because it's greater than. All right, so if you want to go ahead and graph that, take that information and graph that on this coordinate axes over here. So my B is 10, so that means I'm going to go on the y-axis and I'm going to go up 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and my slope is -1, which is the same as -1 over 1. Remember, that means I go down 1 and to the right 1. So right there, down 1 and to the right 1, down 1 and to the right 1. Okay, I'm going to go ahead and graph this in as a dotted line as neatly as I can. So you should be using your straight edge. Remember to cover the entire width of the graph with the line, and then I'm told to shade above because it was greater than. Okay, so I'm going to go ahead and neatly, remember we talked about using these nice, neat, straight lines. I'm going to neatly shade above. Okay, now one thing that's different with systems of inequalities than just with one inequality is that I need to include a label because I'm graphing two inequalities, and so I do need to put a label on here for each of my lines. So I'm just going to kind of stick it down here. I'm going to say y is greater than 10 minus x and just kind of put it next to the line, okay, that's what that one was. All right, let's move on to the second inequality. Okay, so the second inequality was y is greater than or equal to 3x minus 5. Okay, that one already has y by itself, so they did us a favor. We didn't have to do any manipulating. Okay, we're ready to just go ahead and name what is our slope and what is our y-intercept. So here our slope is 3, or 3 over 1, and our y-intercept is -5. Okay, I would definitely say that we have here a solid line, because if there's more to the sign, then there's more to the line. Remember that little saying? Okay, so solid line. And we would also say that we are going to shade above again. Again, we have greater than, and that tells us to shade above the line. All right, so now I'm going to go ahead on the same coordinate axes, and I'm going to plot my y-intercept of -5. 1, 2, 3, 4, 5. Okay, so get that point plotted on there, and then my slope is 3 over 1, which means I'm going to rise 3, 1, 2, 3, and run 1. Rise 3, and run 1. So get a few points on there, so you get a nice, clear idea of what you need to graph. We're going to make a solid line. So I'm taking my ruler. It's a little bit off here. There, that's better. Okay, so I'm going to go ahead and connect that, make my arrows at the end, and then I am shading above. So above this is in this direction. Now look at how nice it is if I made those nice straight lines, because I can very clearly see. It's also cool if you use two different colors. So if you have that available to you, please feel free to do that. All right, so I can clearly see where they intersect. It kind of forms a checkerboard right in this region right here. Okay, so that's where my solution set is. But before I jump into that, please make sure you label both of your areas. So I'm going to go ahead and label my other inequality as y is greater than or equal to 3x minus 5. All right, next thing I want to do for the system of inequalities is I do want to label my solution set. Now think about it. When we had systems of equations, I always wanted you to name that one point where they intersected. That was very important because that gave the answer. Well, here we have a whole area, a whole region that indicates our solutions, any of the points in this crisscross area here. So I'm going to put a big S in this area here, and that's what I'd ask you to do. A nice S, because that's my solution set. Any point in that crisscross region is my solution set. Okay, so if I just went back to my 2 points that I was given originally, okay, the 2 points that I was given were 3, 8 and 5, 9. So let's check out where is 3, 8, which we said was a solution to the system. So if I look for the point 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, is it in that crisscross region that I have the big S? And I would say yes, it is. So it makes sense that we said yes, that was going to be a solution to our system. Okay, let's check the point 5, 9. Where is that? So let's count that out. 1, 2, 3, 4, 5. Up. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can see here this point is a solution to the first inequality, which is what we said it was, but it is not a point in the second inequality, thus making it not a solution to the system of inequalities. Okay, good job. We're going to go ahead and move on to exercise number 2. Okay, number 2 says, on the grid shown below, graph the solution to the system of inequalities shown below. State a point that lies in the solution set and one that doesn't. Okay, so we're going to do exactly what we just did with the last example. Okay, so we're going to identify our first inequality, and we're going to go ahead and go through the process of graphing that inequality. You can see that they nicely already got y by itself on the left-hand side, so I don't have to do any manipulating. All right, so I'm ready to go ahead and name those 4 things that I need to identify before I graph. Slope, y-intercept, then I need us to write down if it's a solid or dotted line and where we're going to shade. So I want you to go ahead and do that right now on your own, and then I'll come back to you in a second and let you know if we agree. Okay, so I think you should have had enough time there to name the slope as negative 3 over 2, the y-intercept as positive 2. All right, now, is this a solid or dotted line? I would definitely say it's dotted because it does not have an equals to. It's just less than. And because it's less than, we are going to shade below. All right, so I'm going to go ahead and put all that information onto my graph. So my y-intercept is positive 2. I have a slope of negative 3/2, so I'm going to go down 3 and right 2. Down 3 and right 2. All right, I'm going to go ahead and take your ruler and connect those and make a nice dotted line. Okay, and then I'm going to carefully and neatly shade below. So this would be the region that is below the line. Okay, before I move on to the next one, this is oftentimes a forgotten step. We are going to label the inequality we just graphed. So y is less than negative 3 over 2x plus 2. All right, moving on to the second inequality. Okay, x is greater than or equal to negative 2. Whoops, I didn't mean to cross that out there. All right, so if we look at this second inequality, we want to think back. We actually did one just like this last time in our notes as well. x is equal to negative 2 is what kind of line? Remember that we should have that memorized, that this is a vertical line. Okay, so it's a vertical line. I don't need to worry about slope or y-intercept. What I do need to ask myself is this going to be solid or dotted, and where am I going to shade? So I'm going to be able to say that this definitely is solid. Okay, and as far as shading, remember when it's a vertical line, we don't have an above and below. But what we talked about last time is we have a left and a right. So we're going to shade to the right. All right, so I'm going to go ahead and graph the vertical line, x equals negative 2, which of course is going to be 2 units to the left of the y-axis. And it should be a nice solid line. Okay, and I am going to pick values of x that are bigger than negative 2, which is why I am shading to the right. Okay, all of these x values would be bigger than negative 2. Okay, so you can again see this nice crisscross region that indicates our solution set. Don't forget, before you move on though, make sure you label. So x is greater than or equal to negative 2. Get labeled. All right, and the last thing we need to do is put a big S in our solution region there. So I'm going to put an S right there. That indicates all of those points in that crisscross region are part of my solution. So we have to go ahead and name a point in the solution set. Now remember last time I talked about, don't be fancy. Name a nice and easy point. If the origin is in your solution set, I'm going to name it because I absolutely know the coordinates of the origin as 0, 0. So I'm going to just use that point. A point not in the solution set. All right, well, we need to find a point that is either not highlighted at all, not shaded at all, which is, there's not very many of them on this graph at all, or we need to find a point that's shaded by one of the graphs and not the other. So if I look, okay, I'm just going to kind of stay in my positive zone so that it's nice and easy. So if I pick a point over here and I went over 1, 2, 3, 4, say, and up 1, 2, 3, 4, I would say that this point, 4, 4, is in the green zone, which means it's x is greater than or equal to negative 2, but it does not satisfy the blue sketched inequality, which is y is less than negative 3/2 x plus 2. So I would say that is a point that is not in the solution set. So I'm going to go ahead and use that point for 4 for that answer. Okay, so this is the end of this video. We'll see you in class next time where we'll be practicing some more of all of this. Have a great night.